Good afternoon, everybody. Thanks for joining our sessions. My name is Sunil Kakade, and I'm INTG Director for Sears Holding. And I have my colleague Ashish Chandra, who is DVP for Legacy Modernization. So we're going to talk about interesting topic here. It's kind of a two ecosystems colliding in this INTG space, especially like the mainframe, which is existing for several years. More than 3 to 4 decades, and now we have Hadoop. And these two ecosystems started coexisting a couple of years in Sears, and we started looking into different kind of use cases. And one of the use cases we found compelling was that how can we take advantage of Hadoop's batch processing capabilities and move some of our mainframe stuff and offload in a way that like it complements to each other. And so what we are going to do today is walk you through this journey, and it's going to be two-part sessions. I'll walk you through some of the technical stuff, and then Ashish is going to show the value proposition of this use case. So one quick question to audience: how many of you worked in a mainframe? If any of you? Okay, it's good to see you. It's very interesting that like most of our Hadoop journey and some of the use cases were implemented by the mainframe folks. I personally come from the mainframe background and transitioned to big data space with the Hadoop as a skill set. So let me go to the next slide. So the mainframe migration has been existing for some time. People were moving from mainframe to client server world, then they started moving into the Java J2E space, then they started moving into a package implementation like SAP. So it's a part of modernization. As business needs changes, people try to go to the modern system which are more flexible, scalable. And that's the idea of the mainframe migration. We still run a lot of mainframe in Fortune 500 companies, even in the Sears. We have several mainframes. Just last week, we took one mainframe off completely, taking about 900 MIPs and moving those to Hadoop world. That's a great accomplishment, and we got that done in 1 year's period, which we could not do in past any time. By the way, just for this is the talk in the Hadoop economics. The big benefit we have here is if you have to run anything on mainframe, one MIPS that cost you about $5,000. And what we started seeing is, as a part of our use case, we could offload some of these MIPS very easily on a Hadoop. We got to do a lot of parallel testing, but once we got stabilized, we started seeing the huge ROI on these kind of projects. So the big data, the big disruption which is coming in, that's a major challenge for all of us. Earlier, like companies like ours were getting a general data like a sales and purchase orders, that kind of a standard enterprise data. But with the big data, more information is coming. So it's not just about the sales, it's more about the context of a sales and unstructured data. And we were looking for something that can reside on our enterprise system. Mainframe cannot do that. Mainframe still is living in the structured world with heavily relying on the relational databases. So we had one of the challenge, and we had to start moving that away from mainframe and find a new platform. And fortunately for us, Hadoop was a good viable alternative. These are the challenges. The biggest challenge in this whole circle to us is like the cost reduction. The data is growing, so the computing is growing. So we need to find an alternative platform where it's cheap to run more jobs, more batch processing jobs, and store more data. And great news with Hadoop disruption is Hadoop is providing us both options here. Is I can keep data as much I want because it's cheap to retain, and I can process data as much time I want. So earlier we used to run the batch processing for like 8 hours, 12 hours. And one of the application which I have to deal with where I was running a job for 4 hours and the need was to run 30 minutes. How do I do that? I have to compress my batch processing window, and the only way I can do that on mainframe is to add more capacity, and that's very expensive. So we found a way to run this in Hadoop, and I can run this in 30 minutes very fast. And I meet my service level agreements and the batch processing windows. Another thing here in terms of the enterprise challenges is like the business requirements, like the retail world is changing and we need to build systems very quickly, rapidly, and sometimes like we need to build something for which we don't know the answers, like we have to go and dig down into the data, find out what it is, and then start building systems around that, and which is why we are excited about Hadoop, because Hadoop I can store data as much I want and enable these two different tools where people can go and mine the data and find out what is the trend, and according to that you can start building the new requirements and build the systems. Okay. Mainframe migration value proposition, we do have. So, the big value proposition here is typically the 60 to 65% reduction in the MIPs, like we started observing, because I can take the mainframe process which is running for hours and move it to Hadoop and take out some of the MIPs. That is a big value proposition. Second thing is that like the cost reduction, and from like use case point of view, like if you want to show something with a good ROI, you can easily do that by picking a high consuming mainframe jobs and finding a way to rewrite that in Hadoop world. The three different ways you can do is, one the mainframe migration is find which is unnecessary to run, take that out. The other thing is like rewrite this into Hadoop big world and then move that, and then there are some applications they still run in the CICS, which is like a dumb terminal where you go and enter something. You can move that to Java front end and the back end into like some MySQL. So that's a third way of moving away from the mainframe. This is a legacy riding the elephant. So Hadoop really disrupted as soon as Hadoop entered into our enterprise, like whole ecosystem which comes with Hadoop started disrupting the way we are doing computing in our INTG shop. It's not only the batch processing, but also like data warehouse side of the world, the way we store the structured, unstructured data. So the biggest win we have found so far is like start moving the batch processing in a way that business doesn't see the change. So we buy in that, like okay, business says there won't be any change to your side. We just go behind the scene, convert our batch window, do a parallel testing ourselves. Ashish has a big team which actually does that, and then move it slowly. So the pieces which are extremely critical, we are not touching it, because that's one of the thing most of the time mainframe migration felt challenge was, like if you are trying to take whole system and move it, then you get into trouble with the parallel testing, getting business partners involved, they are signing off and all that. We basically saying is no, let's find out what is really the big benefit part and then move alone that. So why Hadoop? Obviously the cost reduction. The biggest thing what I would say is benefit is, for a mainframe until now we never had a strong alternative in terms of a fault tolerance. Like mainframe is always like high availability type of infrastructure and ecosystem. With Hadoop, and Hadoop as it brings the fault tolerance with it, it is very appealing that like I can go back and I can recover from anywhere I want, and that's why like earlier distributed solution to mainframe migration were like a single point of failure, and they were not very viable. People will always go and say, hey, look, I cannot run mission critical thing. If one server blows, I am out of it. In case of Hadoop, my data is distributed into hundreds of servers. I can increase my replication, so I have a guarantee that I can have more data. Some of these slides got so I think Ashish is going to come back and talk about this these slides back. So I'm going to go further and come back to. So this is our ecosystem which we have put in a place right now. What this is like, all the data sources. The biggest challenge with mainframe is this. In mainframe, you can still write a programs by using multiple language. It's not just one language. You can use a COBOL, you can use EasyTree, PL1, you can use a Telon, And any shop you go, you can see this whole journey of different programming languages on. The next challenge you have is the data. In a mainframe, data is not only stored into relational databases, it is still stored into hierarchical databases like IMS, it is in Focus, it is in it's on a VSAM, it is in the flat file. So, name it like this whole mainframe ecosystem is grown for 20-30 years and has so many components. And the beauty about this now is like with the Hadoop becoming at the center, I can move this data from all the sources, get into a one platform. I can store there forever and I can process it efficiently on one platform. So, the lot of savings we are seeing is coming from ETL world. You got to invest first time, like what was happening is like if I have data on IMS, then I have to bring it to some platform where it can talk to DB2, or I may have to bring all these things into MySQL. So, we are spending a lot of time just moving the data. Now, like our approach is like get the data into Hadoop first, process it and then distribute where it needs to. In ecosystem, like what the biggest savings we got is like initially we used to write the map reduce using the language like Ruby and Java. That's a long way to go. So, we started using a pig, and pig is very comparative to like our more like mainframe procedural languages. So, most of our mainframe programmers were easily able to grasp into pig and got into the Hadoop bus. Like the key concept here is Hadoop is taking a center place. The other satellite systems are bringing the data. As you notice, the social and web unstructured data is also coming into Hadoop. So, in future I can build a system where I can have a part of data coming from a structured world, which is like my sales information, and I can find out what is the sentiment about in a particular product in an unstructured way. So, those things are going to start marrying with this Hadoop as a center. This is a system modernization. Like what we did is like over the period we achieved a good maturity about moving the batch processing to Hadoop world, but we also always had challenges with the what about other legacy systems, the systems which are running on Informix database or running on the Oracle, running on a DB2, and we still pay a lot of licensing on that. And then as soon as we start finding the success of mainframe is appealing to other people, we started going into or making the use cases that why not move something which is running on a UDB or the DB2, why should pay licensing for that, or like can I take something out of a Teradata and move into the Hadoop. So, basically we were able to prove and we do have a lot of use cases running in production where we have moved the data from the proprietary databases and got into the Hadoop. So, eventually what is happening is there are two worlds evolving as you see in this circle. The bottom world is the processing capacity of Hadoop. The top world is like visual things. Earlier we used to run the grid application either with .NET or the mainframe CICS type of application. Now we have a completely open source based Java J2E framework for the front end application. I can go to MySQL open source again for the persistent. I use a Hadoop for processing all of these things. So, I am going two modernization happening. One is I am bringing the capacity of a Hadoop, but in addition to that I am also driving this open source evolution in our company, where the applications are slowly moving towards open source more flexible world, and the new ecosystem is evolving, ecosystem which still coexist with the mainframe ecosystem legacy, but it's the modernization is happening as open source and Hadoop is coming big time inside. Quickly here, batch processing characteristics, it's a large volume of input data processed, and then typically it is with the batch window. Most of the companies which run on a mainframe, they start their batch window in the evening when users are gone home, they process all the data and bring it back. That's a typical, but now if you have to go to near real time, like for example the fraud detection, you want to quickly detect like something going wrong in a half an hour or like 10 minutes, and if you have a several business rule to run, you need to have a process where you can run it very quickly at particular the batch windows. For example, during the holiday period I need to run it faster. Some of the batch, like what we were able to accomplish was the processes which we were running for 4 hours, 5 hours, we were able to reduce that up to 30 minutes, some cases 15 minutes. And one classical example is like we used to have a 3 billion, 3 data sets of a 3 billion rows, and if I was processing that for almost 10 hours, and once I got those 3 into Hadoop, I was able to do in 17 minutes. Because the bigger data, Hadoop really beats any other system. I mean, if you go into lower and lower, other system may beat you, but as soon as you go to the bigger data, it really solidly beats you. One other example I would quote is, after 2 billion rows in a DB2 table on mainframe, it started choking. You can't do anything. The same thing with 50 to 60 billion million rows into MySQL, it starts choking. I was able to put one data set of, if you take a Sears, we sell a lot of appliances and apparel, footwear, and we have Kmart as another business. So, if you take collectively the combination of product versus the store, it goes in billions. So, one of the things which we were able to do is like I can put all of these things up to 15 billion combinations in one data set, and not only that, like I can query that using either Hadoop or Pig in less than a minute's time with our cluster size about 400. So, those are the things which we could not do in the past, we can do it now. You can have data sets of larger and larger sizes, and you can run the queries or the programs on that much faster. So, the key about the batch processing, you need to have a sufficient storage, you need to have a processing capacity and job scheduling and programming utilities, and this is perfectly what Hadoop provides us. These are the traditionally batch processing characteristics. Mainframe and IBM did a great job in that, and they ruled it until they're still ruling, but there was no viable alternative for these 4 things. And now Hadoop, the cost is a lot cheaper to store, so we can keep the data forever. The availability processing capacity, you can as much node you want, you are processing faster. Job scheduling, Hadoop brings its own job scheduler like job tracker, so that's an added thing. And then programming utilities like Pig is very rich language to do pretty much what we used to do in a mainframe world using COBOL and JCL type of stuff. If one of the classical example is we took a program which is a 6,000 line in a complex COBOL program, and we were able to write that in about 50 to 100 lines of a Pig program. So, what one disruption or the one added benefit you are going to see is the legacy code which was running in millions of lines, because the way the programming languages were structured is going to start getting compressed. It is going to be much more readable, because like the power of Pig is that like you can have a particular business rule can be coded in 1 or 2 lines. So, the compression of a code, maintenance of code is going to be added advantages. The bigger benefit we saw was like when we started doing the new code, instead of coding into COBOL, we started coding into Pig, a substantial reduction, I think up to 70% reduction in the coding itself. Because the way you code in Hadoop Pig is it's interesting, like you are actually coding as you testing, you can't go wrong, you test it, move on, test it, move on. And since the number of lines you are coding is very less, your speed of programming is faster. So, those are the additional benefits you will start seeing it as soon as you get into these use cases. At this stage, like I'm going to go back and talk about this one quick picture. So, the traditional mainframe migration challenges were like you have to move everything, and then you engage with the vendor, and they come with you and ask you to commit them for 2-3 years, and they say I have to move your data into this kind of distributed database, and it's a long term engagement. You don't see quick ROI. So, what we are doing in this picture, you can see user interface and data source that goes into the batch processing, and batch processing ultimately distributing data to the data warehouse, like you might have Teradata or something like that, as well as it is distributing to the external system, and it is retaining into historical data sources. So, what really we did here is like, I want to just take the piece which is painful for us and take that to Hadoop, process it and bring it back. By doing that, what we are doing is business is not really seeing what's happening. I'm gaining the incremental value and ROI for my projects. So let's say there is a 20 MIPS job, right? Each MIPS cost me $5,000. That's like if I take that out, it's going to be save me $100,000, and that's a pretty compelling case to take that one job, rewrite into Hadoop and move it and demonstrate that like, okay, look, if I stop the job on mainframe, your mainframe MIPS capacity is going to be, the need is going to reduce, and you can see I'm able to do the same thing on Hadoop. So we did that, like in fact we took in very first things we took about 300 MIPS out, like that's kind of $1 million in saving, and demonstrated that like how I can use as a Hadoop. That was my one ROI case, and then with that you can start demonstrating the value of Hadoop in organization. So quickly technical stuff, like if you look at the batch processing in a mainframe, those who knows JCL is the basic unit. JCL has multiple steps. Sometime one of the steps kills you running for the hours and hours. You could see what the logic for that. So in this particular case, you have a JCL 1, 2 and 3. And like if I see JCL 1 is a painful, which does like a run a COBOL program, so it does a sort. I can go and just take that JCL alone, move out to Hadoop, write either into Pig or MapReduce, and whatever the output. So match the output of my JCL versus this new Hadoop processing output, and if that matches, everything looks good, then I can move that back to the next one. This is a low risk, high return use case, because in this case I'm not really, I'm making sure everything works fine. I'm not going and asking anybody else to invest the time with us. It can be done behind the scene, and then show that, okay, look, your batch window also got reduced, because we have seen that like some of these things which will run for 45 minutes will start running in 2 minutes in a Hadoop world. So this particular job which would have taken 45 minutes will run into the overall batch window will start compressing. So I think I got one more minute, right? This is those who worked in mainframe, they can easily read this code. This side is a JCL, you're writing these many lines of code to find out, okay, sort, like, we had a 500 million record in one data sets, and it was taking a 45 minutes to do certain kind of operation, and we just loaded that into Hadoop load. That's one line statement for Pig load, load the data into basically your HDFS you are attaching to the back called A and doing an order. So there are many benefits we have seen. Right now, like we have hundreds, about thousands of jobs running on our Hadoop cluster. They were migrated from a mainframe in the last 1 year, and we took last week one mainframe out. That's a substantial savings for us. So I think we are going to go back, and Ashish will talk about some of benefits, and then we'll go back to the question and answer later.
You can go back to benefits.
Yeah.
We want to give you sufficient time to ask questions and get more in detail. So for now, I think I'll skip the slides and get to some of the key information for you guys, which is really the hard-hitting bottom line information that is going to be helpful to you. Mainframe migration, those of you, I saw many names and many hands rise up when we talked about mainframe migration. They are infamous for failures. Organizations try mainframe migrations once, twice, 3 times for over a period of decades, and they're unable to migrate from their mainframes to new technologies for a good reason. They're very, very difficult. And they're very difficult because there's a lot of complexity involved. They are painful, and they're very, very expensive. There's a huge motivation to move off of mainframes. And our journey has been more like this. We started with, we knew we wanted to get off of mainframes. And we also had a vision in terms of entire data architecture. And we also wanted to be disruptive from technology standpoint, but not disruptive from business standpoint. So how do you come up with something which is low risk to the business, We're not really changing the front end, which is going to be ridiculously cost effective. It's going to give you so much money savings that you can justify any project which is internal to INTG departments. We also wanted to, in the process, create an opportunity for ourselves to do so well in mainframe elimination program that we start our own business practice, which we did, by the way. So I'm heading application modernization for Sears Holdings, where our goal is to look into all legacy and proprietary technologies like mainframes, like Netezza, anything that's not making sense and anything that we can use for its strength and leverage that strength in Hadoop. So really a strategic move into newer technologies is what our goal has been, and does not happen on day one. It just happens slowly. We take one step at a time, we show the ROI, we show the benefits, and numbers are astronomical. I mean, we started 3 years ago, and we have made a lot of mistakes. We didn't know how to ingest data into Hadoop. We didn't know what was the most efficient way of exporting it back into, let's say, mainframes or Oracle or whatever the database might be. Our ETL processing was just really, really horrendous. I mean, it was a nightmare. We had actually been copying and pasting data. It's like sourcing once and then, every time we copy it for ETL processing. We were using so much of workload on mainframes, on data warehouses, that it was just not making any financial sense for us. 3 years, started with 8-node cluster in Hadoop environment, made a lot of mistakes, burnt many times, have all the scars that you can think of. And today we have 834 nodes in our clusters, which includes production. There's 3 clusters, of course, backup and integration, testing servers. So we have all these clusters, and we are getting to around 1134 nodes cluster within the next 3 months time frame. We are moving a lot of workload off to Hadoop. And the reason mainframe migration becomes one of the most compelling cases is because it's one of those success stories that you don't hear about. And it may seem overwhelming initially. It may seem something that one cannot achieve because those targets are difficult. Every one of us who's worked in mainframes knows each MIP, it takes a lot of effort. It costs a lot of money, depending on which organization you are from. If you are, and by the way, from MetaScale standpoint, we are providing services to healthcare, oil and gas, retail, financial, banks, all of them. And all of these different organizations have variety of MIPS consumption. Some of them use 10,000 MIPS, some of them use 50,000 MIPS, depending on what industry and what business you are in. How do we leverage big data to actually lay the foundation, modernize our applications, modernize our technology, and then lay the foundation for analytics? That's where the business gets the value. We are able to use Hadoop for archiving purposes. Don't use tape anymore. You don't really need to. You can actually use Hadoop for archiving purposes, and you can spend a fraction of the money you're going to spend otherwise from storage standpoint. You're going to use, and you will yet be also able to actually use it for near real-time query purposes. Data storage, that game has changed for us completely. From cost efficiency, we, Sunil just mentioned this last weekend, we actually took out a mainframe. How many times do we get to hear that? The typical standard in the industry is 6 to 10% growth on mainframes just from organic data. You're having marketing departments, you're having supply chain departments. Your supply chain guys are going to try to get the PO, the purchase orders, created at the detail level, because this is a world where consumer personalization is key. From marketing campaign standpoint, you want to be able to tailor your marketing campaigns for a consumer. You want to know everything about your consumer. So essentially what you're doing is getting to that level of granularity of data, more volume of data, more latency in data. You're going to consume more capacity on mainframes or Teradata or any other technology. What we propose is a hybrid approach, an ecosystem, not just one technology. We're saying a combination. Hadoop is really, really good and very powerful when you talk about billions and billions of records. It's not so good when it talks about smaller, less complex queries. That's where you use something like a relational database or something else, which is going to be really good in doing something not so complex. So you make a hybrid approach where you use the strengths of the technology that makes most business sense for your company. Our approach has been similar in those aspects. We wanted to start small. We wanted to make sure that we had proven a use case. We have moved stuff from mainframes. We have taken out 1,500 MIPS last year alone. We have taken out a mainframe from our actual mainframe footprint. So if you have, let's say, a dozen machines or half a dozen mainframe machines, imagine taking a machine out and not actually going to your business or board and asking for that money to increase the volume because of the holiday growth potential adding more to the mainframes. Because when you are having these negotiations or discussions with IBM for contract renewals or with Teradata, all these companies, and you're actually cutting costs by reducing fewer MIPs or by reducing less workload on your data warehouses and leveraging Hadoop for its strength, then you truly get to use and fund some of those other analytic initiatives for your company from the IT department alone. From the business standpoint, you are now being able to provide value from lower risk. As Sunil mentioned earlier, we don't necessarily change the application. We don't want to. We want to keep the front end the same. So we yank out right in the middle of it, we yank out the processing and move it into Hadoop. That ingestion process, it depends on what technology we are using. If you're using relational databases where we are pulling it from, then we use Scoop. If you're pulling the data from DB2, let's say, mainframes, then we have custom scripts for that. And then the whole process of feeding it back into mainframes for the output files. And we compare them. We make sure that the data is matching 100% before we actually decommission the mainframe processing piece of it. So that gives you some idea about the financials, the economies of scales we're talking about. You're increasing scalability. We have jobs that were, as Sunil mentioned earlier, that were taking 18 hours. I mean, you have pricing job that once every night you need to send the prices to the stores, or you have batch processing that happens. These jobs are taking anywhere from 6 to 18 hours every day. And if something goes wrong, you don't have enough hours in the day to actually fix it and then run the same job again. So you just miss on that data. We are now able to run those jobs in a matter of minutes in Hadoop. The processing is improved 10, 50, 100 times better than running on Hadoop. So from the processing speed standpoint, we have found that Hadoop has truly been a game changer for us. So that's just not from mainframe standpoint. We're talking about anything that's legacy, anything that's proprietary. If we use Hadoop for its strength, if we use Hadoop as an enterprise data hub, that's another key factor in our entire overall strategy. We have really evolved into finding a way to actually use Hadoop as an enterprise data hub, where we don't have to use ETL processing and then use the consumption and end up paying a lot of licensing costs to, again, data stage or whomever you might be using. Instead, use Hadoop as a data source in one data hub where you source the data once and then you reuse it multiple times. So in an effect, you're modernizing the entire concept of ETL traditional processing. So it really takes a lot of changes in your mindset and the way you're approaching it. What our recommendation would be, some of the lessons learned. I'll skip to that slide. We'll get to the lessons learned in a minute. Some of the benefits include, a lot of money. It's just a phenomenal amount of cost savings you're going to see once you start moving stuff out of mainframes and you do it successfully. And we saw some results very quickly. It says that it was 1,000 MIPS reduced by moving batch processing to Hadoop. And this is just the batch processing we're talking about. We have moved online transaction data. So we have applications that we have moved entirely, not just the batch processing also. And the money is just, it comes with it. Entire applications, we are moving COBOL JCL to either Hadoop or to something else. Hadoop is always not the right solution. We have to keep that in mind. Hadoop has its own set of challenges. There's a huge learning curve. We went through that, and hopefully it wouldn't take any of you guys 3 years to go through what we did. I think you can do this in less than 6 months if you follow the right processes, if you had the vision in mind, if you kept in mind that there are enterprise data hub considerations to keep in when you are going through this. It does not necessarily talk to legacy very well, so you have to make sure your data point connections are really well with that, integration is going well. There's a lot of lessons learned in there. But look at the 7,000 lines of COBOL code. There's many COBOL developers I'm hoping here, and who would truly appreciate that you're writing code that same logic in less than 50 lines in Pig or up to 100 lines. That's efficiency, that's maintainability. Now, we have developed a program where we actually train our COBOL developers into writing Pig code. And it's not very difficult. They pick it up very fast. Sunil and team have actually helped tremendously in that effort to train our mainframe guys into becoming Pig experts. The biggest challenge they come across actually is training onto Linux. Pig is actually easy for them. So, of course, the operational efficiencies, and you can't find mainframe developers much. So, you really want to move them into the newer technologies, which is good for them and for your organization as well. And of course, the efficiencies in jobs and the moving. Let's see if we can get to some of the lessons learned, then we can field some questions for you. Some of the use cases here show how how we have been able to save huge amount of money, but not just that, but also being able to do things for business like price optimization. It would take us weeks to run price optimization cycle. Now we can do it whenever the business needs us to do it. So we were really prohibiting the business. We had too much data that the whole processing thing would take too long for us. Now actually we can deliver what business needs and get to ask the questions we did not know we could even ask. That's the key thing. Many people are unable to ask the questions from the business side because they don't know. They have never been able to get that level of information from technology departments. Now they can. Some of our learnings include, you can dramatically reduce batch processing, of course, retain analyzed data. It needs to be part of the overall solution. Please do not think that Hadoop can replace everything in your company. It does not. We have learned it, and this is one thing if you take away from here would be, it needs to be part of the ecosystem. We are not suggesting you get rid of all Teradata or Netezza or mainframes for that matter. What we are proposing is you could save huge amount of money, improve efficiencies, operational efficiencies, performance, all of that by using the technology for what they are really meant for. Don't use, let's say, you could use Hadoop and you don't have to use a lot of processing, which is going to consume a lot of MIPs or a lot of workload on different alternate technologies that you can use and leverage Hadoop for. So it needs to be part of the ecosystem. It helps you reduce your data latency. We are able to meet our production schedules, eliminate ETL loads, as we talked about earlier, and improve user experience. We built tools. We have been able to file for over a dozen patents in last year. And that's one of the reasons why, because we were able to find ways and crack the way of using big data for the business, really being able to take workload off of mainframes or other relational database, proprietary databases, or other technologies that are truly proprietary, and move that workload to mainframe. The process of ingestion, the process of processing, the process of putting it back in there, that's where we have our most of our patents in, and then we have been able to launch this company called MetaScale, where we provide those services to new customers now. All right, I think we want to leave a few minutes at least for Q&A. If you have any questions, please, you're welcome to ask now. So the question is, because he doesn't have a microphone, he's asking that what are the kind of techniques that you guys use for the data ingestion purposes into Hadoop? Sunil?
Okay. So two part of the questions, right? The key thing is like when you, let's say you start your Hadoop project, the first challenge is like you got to get data there. And if you are starting your project with mainframe, where the data is stored in its own format, like packet format, so that Hadoop doesn't read that. So this is where like you have to build your own tools or utilities to unpack that and bring it in the format which Hadoop can understand. That's the biggest challenge to begin with. So if it is a DB2 table, and this is what we learned, like you can do something called a scoop, which does a JDBC connection, bring the data. But if it is like a millions of rows into DB2 table, then you have to use your mainframe skill expertise to find out how you can unload that data faster. You could use a device strategy of breaking that into multiple jobs, but we prefer like use unload utilities of a proprietary system to bring the data back, and then you move it to Hadoop. So if you look at, there is going to be IMS, there is going to be vSAM. What I'm trying to generalize is if the data is on mainframe, it is best to write one job or utility which can offload that quickly for you. But if the data is on MySQL, use like a scoop tool which comes with Hadoop as open source. If data is on Oracle, try to use their own. We bring a lot of data from Teradata. We use their fast export utility and then move it. So really when Ashish is saying experience, what we learned is like each data source, there is a unique and optimum technique to bring the data into Hadoop. So we spend a lot of time to figure it out what makes sense. Usually like people tried running the scoop on Teradata and we got killed ourselves, so that doesn't work. Okay.
So
Did I answer your question? Yeah.
To add to that, what Sunil mentioned, I think this is one of the places where we went through the pain and misery to figure it out. And once you know it, then it's all paradise, really. But I like to classify into three major categories. One is real time, if you're ingesting it from. Second is your, let's say, RDBMS or relational databases. And third is proprietary or something like Teradata or DB2. So we have been able to come up with scripts for each one of them. For example, we know that for relational databases, Scoop works well. But even in that, there's a method to the madness. You have to think about the mappers and the reduce and how many should be there. So we have all of that scripted out, part of our patenting process, of course. So we can't go too much in details, but I'm giving you a high level. So scooping for relational databases. Real time, we like the tool Fume. I'm not sure if you've heard of that technique and tool, which really works well for us. We're liking it very much. And finally, we have custom scripts for something like DB2 where we do the unloads, or Teradata where we use our custom scripts. So that's the major three buckets that we have classified all of it. Hopefully that answers the question you're looking for.
Any other questions? Yeah. Any other questions?
Yeah.
Yeah. Can you come to mic, please?
Hi. For mainframe data ingestion specifically, what do you use for the data transfer? Do you use FTP? Do you use FTP over SSL? And the second question I have is that what happens to the metadata? Do you have lineage for metadata? Once you move, it's going to be always on Hadoop, or do you have anything tracked?
Okay.
Thank you.
Good question. So we use FTP, and then second question the answer is yes, metadata is important. So when I move the data to Hadoop, I bring the metadata also to process for the when I'm running something in a pig language. So the schema is important to move into Hadoop. But the good news here is the schema doesn't stick it, right? You can apply the schema whichever you want when you are coding your pig scripts. If we don't have any questions, I just want to quickly recognize my team in Hopman, Ted Woodman, who is my DVP. He led this effort with Ashish, and Simon Thomas, who is a director, and my team, Susan Su, who was Susan, Bob Pult, Kim Heavens, and Vila. These people actually did programming in COBOL for 15 years, and we were able to train them in Hadoop, and now they are training other people into Hadoop. And we do have people coming from a Java world, and the reason I'm recognizing and giving effort is because this is the kind of team you have to put together. So we had 4 people from Java, like Murli and Nagmani, Arlene, and Tushar. These people brought Java skill. Then I got some mainframe people. So then we looked at Hadoop and mainframe skill set together. Ultimately, both of them, the people coming from Java world started coding pig. People coming from mainframe coming pig. Only negative point there was pig is extensible language with UDF, and people from Java will started writing more UDF, and I have to control them. But the team, you can bring people from any background and get into this technology easily. Okay.
We're going to be here for next today and tomorrow. So sometimes the questions won't come to us right then and there. So you're welcome to reach out to either one of us if you have any questions or like to know more about what we are doing, so we can hopefully help you more in getting towards some mainframe migration goals.
Okay. Thank you very much.
Thank you.